I just want to point out how in this project, which is the fungi project developed in Italy in 2020, I would like to point out how to plan and to perform monitoring and sampling organic pollutants according to which result we want to reach. We were involved in this project, fungi project. The coordinator was A2A, an energy company in Italy, which manage many waste-to-energy plants, especially in northern Italy, and also university and private institute were involved in this project for the scientific evaluation of the results, of course. And the context in 2020, which is the problem why we decided to develop this project, because in Lombardy, this is a local, it started as a local project, around 1 million tons of sewage sludge are generated every year. They are mainly used in agriculture as soil amendment, okay? But this brings some issues because sewage sludge contain dangerous pollutants for health, of course, and also for environment because of their persistency. And for this reason, we developed this project to find another solution. Of course, in Europe, this is an Italian project. In Italian, the context is what I explained right now. But of course, in Europe, many countries decide to treat the sewage sludge in another way, as incineration, for example. And this is the point of this project. We try to understand, and this is an overview of the project. We try to solve the issue I just mentioned. Of course, the starting point is represented by the sludge, which in 2020, as I told you, was used mainly for agriculture. But then we wanted to understand which is the impact on the environment with another approach, which is incineration. Of course, the waste, the sludge must be treated before the incineration. This project involved many tasks, as you can see, it's quite complex. But at the end, to understand which is the sustainability of using agriculture and incineration, was performed a life cycle assessment. Okay, just to give you an idea, as I told you, we focus on incineration. In the project, we follow two different approaches, the monocombustion and the co-combustion. I don't want to go deep in this slide, in this difference, but just mind that the first step for both it was to dry the original material, the sewage sludge. And then we developed different scenarios to understand which was the best by different point of view. For technical point of view, that means the performance of incineration, and of course, by a health point of view, how these different scenarios impact on the environment and on the human health. So, the main question of the fungi project is how to manage the sludge. The starting point, of course, is to define which pollutants must be considered to produce a reliable evaluation. Of course, the review of scientific literature was necessary. Heavy metals, of course, persistent organic pollutants, antibiotics, and emergent pollutants as PFAS, for example. The next step was modeling. We followed two different approaches, an in silico approach, starting from the chemical analysis, and also an ecotoxicological approach, testing on model organisms the matrices, that means emissions, and also the sewage sludge with ecotoxicological tests. So we go on by defining the health impact of the two approaches, use the sewage sludge in agriculture and also to incinerate them. And this was useful to define a proposal for some policies to understand if a sludge must be, or it's better that can be used in agriculture, or it's better to be incinerated. To do this, we perform something like a backward analysis, because the main point for the policies in this case is which are the concentration in the sewage sludge. If concentration are qualitatively too high, they should be incinerated, otherwise they can be used for agriculture. Okay, so once defined the list of the pollutants to be determined on the matrix, of course we focus on emission. The starting point is official standards. Since we are talking about organic pollutants, the EN 1948 standards are the starting point. Then in my presentation I focus on organic pollutants, but many others, no, the group, heavy metals, for example, were also considered, and they are regulated by other standards which were followed in this project. And then also the scientific literature was consulted, because to find some ways to build the sampling line, to perform the sampling of these emissions. Of course, as stated by EN 1948 standard, the sampling method that allowed by this standard are dilution method, cool probe method, and filter condenser method. We focused, of course, on a filter condenser method because we are producer of a fixed sampler, which is the DEX, dioxin emission continuous sampling. We can be installed on the waste-to-energy plants, or any plants where we have to check to control the emissions, the organic pollutants in the emissions, and which is compliant to the standard. And it was used on every plant, but this was also the starting point for 2 other experimental lines. You see in this, in this box, an experimental sampling line, all built in glass, so that it was also compatible for sampling PFAS according to the US EPA OTM 45. And it's really similar to this one, to the standard, but we added 2 steps where the condense is collected at different temperatures. And then another line to perform ecotoxicological test, where we eliminated the filtration and the adsorbent step, and we collected the overall emission as condense. So it was possible to test on the modeling organism the emission, to understand how toxic it was for the organisms. Here I reported you a few results. It's not so important, I think, in this presentation to go deep to the qualitative discussion, to a quantitative discussion, because it's just to let you understand which are the possibilities that this kind of results can open for a project like fungi. Here I report the results for long-term samples collected according to the standard device. And you can see that the main difference are due to the concentration, because the pattern, the pattern is not so different. And mainly, the most important pollutants we found inside these samples are the PAS reported here. but the pattern is not so different. On the other side, I show you just as an example the results of samples collected with the second method I show you, where the filter, the absorbent, and the condense were analyzed. These samples, A, B, and C, are the same. They